Okay, student, today we are going to discuss the theorem number 1.4 according to your textbook. Is that clear? This is root 2 is irrational. However, in the 9th class we already have seen that any prime number, when you will take under a root or the surd sign, this is called surd sign. It means this is theorem 1.4. Okay. We have to prove here this root 2 is an irrational number. Obviously, in previous class we have discussed that if n is if n is prime, is that clear? N is any prime number. So, what will here please do? Under root n, if you will take, so will be an irrational, right now. This concept we have explored in detail in the 9th class, but I am telling you here you will prove this root 2 analytical method, and you will give the evidence for that how root 2 is an irrational. Okay, and theorem means it will work as a ready-made result in the next time when you will study here this. Okay guys, so listen here, we are going to prove root 2 is an irrational. Okay, so before starting that I want to tell real numbers are classified in rational and irrational. Any number if not rational, then it will be rational. If any number is not irrational, then it will be rational. Obviously, means no any numbers could exist here which is neither rational nor irrational. However, in the 11th class we will study about a third type of number is called complex number. This complex number is imaginary concept or way of explaining or expressing the numbers. But listen here, is up to your extent of your study. Real numbers classified in rational and irrational, means no other third type of number are still known by you. Is that clear? So, root 2 is an irrational number. We just have to prove this is irrational. If we are to prove this is irrational, not only this, we are to prove this root 2 irrational. Any number, I think here this also can be taken as a root 3, root 5 and root 7, root 11, root 13 and so on. All the number means under root will be irrational, under root prime number will be irrational. Okay, the method and the procedure which will employ to prove irrationality of any prime under root or under surd sign will be same. Simply you will change the figure where they are occurring. Is that clear? So, I am proving this is an irrational. Before starting, I want to tell in mathematics there are a lot of methods are famous: deductive approach and explanatory approach, and we can say top to bottom approach must be there, central approach is there also, and contradictory approach is also there, and contrapositive approach is also there. So, here we are using a contradictory approach. Is that clear? What is contradiction? We suppose certain things and we just later give the evidence or support of this trueness, and after some time we found that this is not true, that it means our supposition became wrong and the concept is not what we are supposing. Is that clear guys? So, contradictory approach, a contradictory approach we are just giving. Is that clear guys? So, have a look here, root 2 is an irrational. So, we are just writing the solution. Before that it is irrational proving, we will suppose that this is not irrational. Okay. So, I am supposing here solution, let root 2 is not irrational. Root 2 is not irrational. If root 2 is not irrational, if it is not irrational, then it will be what? Rational. It will be rational. If it is not rational, then it will be rational. That is, so if it is rational, then it can be written here. Can be written as what? Root 2 can be written as a by b. Means that the form you just know here, p by q form, because every rational number can be written in the form of p by q. Clear? Listen again, I am speaking here this again. Let root 2 is not irrational. If any number is not irrational, then it will be rational, then it will be rational, and if it is rational, then it can be written, that is can be written as, you may say this is right now, and p by q, P by Q means this is prime, this is prime, a perfect rational number here, where you will write here where A and B are co-prime. Do you know the meaning of co-prime? Co-prime means they do not have common any factor. Common any factor like that 4 and 6. Is this a co-prime here 4 and 6? No, of course 4 and 6 are not having a co-prime right now. So 2 is common in them, 3 is there, 2 by 3. Now they are co-prime because 2 and 3 are co-prime. So P by Q is a rational number here. Now come on please further. So A and B are co-prime. We have suppose A and B are co-prime. So further this can be written as further B. So A is equal to B time root 2. Is that clear? It means this will go as, this is called the cross multiplication. However, this is not a mathematical operation. Well, it is, but however we use this concept here, and after that still the irrationality is appearing over 2. So irrationality is to be vanish, to be removed here, So squaring either side, we are doing this, squaring either side. Squaring other side will make here A square is equal to, and what will here this, and root 2 will become 2 and it is a B square. You may see just here. So what type of expression is giving here this? Just you call the concept here Euclid division lemma, A is equal to BQ. It means A can be expressed as a product of Bn. So this B is dividing A here. Okay, it means we can understand here this A, B is the factor of A. So here you will write, since here or here you also write here 2 divides A square, 2 divides A square, the same thing else, 2 divide A square. The previous knowledge that we have discussed the last time, what is that here? 2 divides A square. You understand here this, the theorem we have proved in the paper right now, P divide prime, P divide A square, then P divide A. This is a ready-made result here. It's called a theorem that we have proved yesterday. Is that clear? Now we are going to discuss here further. So what I am writing, P divides 2 divides A square. I think here we will write down that concept here, the theorem that is called, this is that here. You just remember this theorem, what the theorem is called here, P divide A square, then P divide. So 2 divide A square implies that 2 divide A right now, and if any number is dividing A, then what will happen? Then what we can write here, then 2 is a factor, 2 is a factor of, what will I speak here, A, 2 is a factor of A. We will remember this line, 2 is a factor of A. So if 2 is a factor of A, so obviously 2 dividing A. If 2 divide, then we can write here 2 divide A. So A can be written as a 2 into C, not A. So you will write here this, you will see this here, sir, A square can be expressed as a product of 2 in B square, but how A is? Obviously if 2 is dividing A, is giving B square, but 2 dividing A will give you some other number like that C. Okay, again squaring either side will make here, but squaring either side, what is that here? A square is equal to, and it's 4 and it's a C square. Understood? And further, what next could be done? Can be done here. This is relationship 1, second, and you may see this is relationship first. Okay, you may see we can give the name of the equation by the different color, so making it highlighted is okay. It's equation number 2, and this is equation number 1. You understand this here? Where is this? So A square is equal to 2B square in equation 1, and A square is equal to 2C square in equation 2. So we'll write down here this from equation 1 and equation 2. What is that? Here will be 2B square is equal to 4C square. Further, I think 2 common it is, so it shall be B square is equal to 2C square. Okay guys, now see again, here again the concept is approaching, that is called 2 divides B square implies that 2 divide B. Well understood or not? If 2 dividing B, then what can we speak here? This 2 is a factor, of B. Now have a look here this. We have supposed earlier as 2 as you may say this, I think here I am explaining this, A and B prime factors are here. You may understand this. This is the line here. This earlier you attempted where A and B are co-prime. It means there is no common factor between A and B. Just you have supposed when this is not irrational and it is rational and it is rational, then A and B are not having any common factor. So, you have supposed, but here you proved 2 is a factor of A. You may say this 2 is a factor of A, you have proved here. Is that clear, guys? Now, later also you have proved 2 is a factor of B. You understand this? 2 is a factor of B. It was the first assumption yours, A and B are co-prime, and your proof is 2 is a factor and 2 is a factor of A and 2 is a factor of B. What does this mean? It means this 2 is a factor of A and B both. However, you have supposed earlier they are co-prime, not any factors they are common having. So, what this contradiction is approaching here is, already you supposed A and B are co-prime, no common factor are lying between them, but here how the factors approaching. Is that clear? So, what can we conclude here this? We can conclude that here. So, what is this? 2 is a factor of A, okay, as well as B, right now. So, it is a factor of A and it is a factor of B. So, this is contradiction. You will write down here. This is contradiction. This is contradiction to the supposition. This is contradiction to the supposition that, what that, please tell me. This is contradiction to the supposition that what? That A by B, that is A by B was here root 2. It is contradiction to the supposition that A by B is not equal to root 2. That is that root 2 is not a rational. Root 2 is not a rational. Root 2 is not a rational. Therefore, what? It is rational. Therefore, it is rational. Then what is actually the contradiction? It means that, see guys, we have employed all the mathematical operation properly. Here we have our supposition is only by our side. Everything else is squaring, equating, divisions, everything else we have done by mathematical concept. Means we can speak here this the concept of the arithmetic operation which had been employed here are all reasoning, all was logical, and even no wrong concepts were applied here. This only the supposition was our side here. This, so our supposition is wrong. Due to our supposition, actually the concept wrong is coming here. The contradictory situations is rising due to our supposition. So nothing else is wrong here. Only the wrong is our assumption. Is that clear, guys? So well understood you. How can we prove that under root 2 is irrational? And next time you will prove with this. Similarly, you can prove here. Similarly, you can prove root 3, root 5, root 7, root 11, root 13, and so and so on. It means they all numbers are what? Tell please. They are prime numbers. So under root, a prime number is always an irrational number. Okay. You will prove this by deleting this. Here in place of root 2 you will write root 3. Similarly, root 5 can be done also here. A lot of questions are given here in your study material. You may say this. This is your textbook theorem. Root 2 is irrational, we have proved here, and further root 3 also can be done by the same. This is a question. Is that clear? Similarly, 5 minus root 3 is irrational. How we will prove this? It's very simple. It is. So before starting that, I just want to tell 5 minus root 3. We have to prove 5 minus root 3. Look at this solution number. This is a question. Okay, 5 minus to prove 5 minus root 3 is an irrational. So it's very simple. Same the line will be copied here. What we will suppose here? Let will suppose or consider 5 minus root 3. 5 minus root 3 is not rational. If it is not rational, then what? Then it is what? It is rational. Therefore, what can we write here? 5 minus root 3 is equal to a by b. Same it is. We can write in the rational form here. That is called every rational can be written. Every rational can be written as p by q form. Is that clear? So, what is that here? Further transfer to that 5 times b is there, and listen guys, so we have to prove the irrationality here. Okay. So, can you say 5 is rational irrational? Obviously, it is rational appearing here, and root 3 this is irrational. So, they rational and irrational are in the fused state, we can say in the combined state, in the mixed states is there. Okay. So, first we have to separate them either side of equal sign. Is that clear? So, how this can be written as, look, it is 5 minus a by b is equal to root 3. You may understand this. This root 3 transferred to the right and this whole expression is transferred to the left. Further, taking LCM here, it is a 5b. The simple procedure I am employing here, what you have learned in the previous classes. Okay, and even the terms even I am using that already you have heard in 6, 7, 8 classes. Okay, it is b and root 3 is there. Now, what you observe here, a number here, you may see this a comma b are integer. Obviously, a and b are integer. Why they are integer? Please tell me. Integers. They are integer. Why they are integer? Because they are forming a rational number here. Is that clear? They are integers. So, now next is they are integers. So, implies that 5b minus a, 5b minus a means a and b are integer, and 5 minus b is also integer, is integer. Tell me why this is integer? Why this is integer? This is integer because 5 is integer, b is integer, and the integer is multiplied to integer. Integer comes here and again subtracted, integer again comes here. 5 is integer, implies that 5b minus a divided by b is a rational. Tell please why this is rational? Obviously, numerator is integer, denominator is integer. So, integer integer upon integer rational, which is equal to, this is rational, which is equal to an irrational, which is equal to an irrational. That is what irrational here? Root 3. So, you understand here this, a rational number how could be equal to irrational? This is a contradiction is coming here. A rational number cannot be equal to irrational. So, what we will write here? This is contradiction. This is contradiction. This is contradiction to the supposition. To the supposition. Okay. This is contradiction to the supposition that, what supposition was there? That what? 5 minus root 3 is what? Not rational. It is rational. No, is not irrational. Is not. It is irrational. It is irrational. Hence proved here. So, in each question, every question in the same number of steps will again and again come here. Is that clear? You have to change only the terms here. So, again listen again here, this method is completely based on contradiction concept here. Means first you suppose this is not irrational. If any number is not irrational, then it will be rational, and if any number is rational, then can be written in the form of p by q. A by b I wrote here this. Why I am writing a by b? I am just calling the concept of the Euclid's lemma. The term symbol a and b already had been used in the Euclid's. So, it will get best mapping with the term, and even the student can learn easily with the symmetry of the symbols here in the case of Euclid and this here. Is that clear? So, today you have learned here under root n, that is n is a prime number here, 2, 3, 5, 7, 9, sorry 11, 13 is a prime number, they are all prime number. Under root they are is always an irrational number, and here we also approved it, this is a rational number. Is that clear? So, some more question will say that here, this is show that 5 minus root 3. So, we have proved this else here. Similarly, here is also a question here, show that 3 root 2 is irrational, 3 root 2 is irrational. How I will prove this? It's very simple, it is 3 root 2. So, I think everybody can understand this concept here. Solution number third, what is that here? 3 root 2. This is irrational. So, same number of line you will copy here this. These solutions will copy here this. Is that clear? These number of copies and these number of solutions you will give here this. What is that? What is that? That is again you will just write here the same number of steps. Consider 5 minus root 3 is not. So, similarly you will write consider, here you will write consider, what you will write consider, what is the number here? 3 root 2, okay, is not irrational. Again same, is not irrational. If it is not irrational, then what? I am just telling you, I am just making the copy paste of the same statement here, okay. This is that here, this is that, okay. You will understand this. Is that clear, guys? Sorry. Let this is okay. The same solution number of steps will come here. Consider 5 answers. So, we will write consider, not this is. Here you will write 3 root 2. 3 root 2 is not irrational. Then it is rational. If it is rational, then can be written in the form of what? 3 root 2 can be written in the form of a by b. Is that clear, guys? A by b here. A by b. So, further what can be done here? This operation. It's a root 2 is equal to a by b. Sorry, this 3 is transferred to the denominator of the right. It's a 3b here. Well, understood? So, what the next is? A and b are integer. Again you will write the statement. Go back. The statement are again a and b are integer. This statement again you will copy here this. You will copy this. Same to same. Nothing else to change here this. Yeah. This is that. Clear, guys? A and b are integer implies that this is to be changed here. What is next here? A and b are integer is what is that? So, 3b is integer, 3b is integer implies that what next is? Implies that what next? Yeah, a by 3b is rational, which is equal to root 2. The root 2 is that is what? An irrational. That is an irrational. So, what you will, it is contradiction to the supposition. Go back again. It is contradiction to the supposition. This is contradiction to the supposition. What the contradictions you made here? This the contradiction to the supposition. Yeah, this is contradiction to the supposition. This is contradiction to the supposition that again here, yeah, 3 root 2 is not irrational. It is not irrational. It is irrational. Okay. Well, understood you? So, this is the very important question according to examination point of view. Many times I have seen this question comes for the value of worth value 2-3 marks here. Okay. So, you will understand this question here. I hope you will appreciate the some more questionnaires. See the exercise 1.3 in your NCERT textbook. Prove that root 5 is irrational. Can you solve this or not? Prove that 3 plus 2 root 5 is irrational. Same the method I told you. Even the third question also I told you this. Is that clear? It's sufficient for the day. You will appreciate these 3 questions as an assignment today. Exercise 1.3 of NCERT text. Prove that root 5 is irrational. The same you will follow the procedure. If you can't understand, then watch the video twice or 3 times. Is that clear, guys? Thank you very much. Have a nice day.